Hi, my name is Nurul Iza Inshira.
My name is Nur Aina Natasha binti Ahmad Farid.
Hi, my name is Putri Nur Atika Najiha.
My name is Nurul Balkis binti Muhammad Yusra.
Today, we would like to present our project titled Exam Hall Seating Arrangement System. This system is developed to help schools manage exam seating in a more efficient and systematic way. Manual seating takes a lot of time and may cause error, such as duplicate seats and wrong hall assignment. Therefore, this system automates the seating process based on available halls, rows, and columns.
Now, I will explain the problem summary of our project. Manual exam seating arrangements are time-consuming and prone to errors. Problems such as confusion, duplicate seat numbers, and unfair seating may occur, especially with a large number of students. Therefore, schools need automated systems that can assign seats fairly, accurately, and efficiently without relying on manual calculation. After that, I will explain the problem statement. Our project focuses on developing an automated student seating system for examinations to improve efficiency and reduce human errors. The problem statement of our project is how student seating can be identified automatically in order to reduce confusion and minimize the risk of cheating during examinations. So, we go analysis question. A. What problem are you going to solve? The problem that we aim to solve is the inefficient and error-prone manual seating arrangement of students in examination halls, which often leads to confusion and misplacement. B. What are the conditions given in the problem? There are several conditions defined in this problem. First, one seat can only be assigned to one student. Second, students must be seated sequentially. Lastly, once an examination hall is fully occupied, the seating arrangement continues to the next examination hall. C. What information is given about the problem? The system requires several types of information, such as the total number of students, the number of examination halls, the number of rows and columns in each hall, as well as student details like names or candidate numbers. D. How can the condition and information be used to develop the solution? By calculating the total number of available seats in each examination hall and assigning students sequentially based on rows and columns, the system can automatically allocate a unique seat and hall to each student. Therefore, an automated student seating system is necessary to overcome the limitation of manual seating arrangements.
Now, I will explain about the objective in this report. And the first objective is to identify and display each student's seating location clearly in the examination hall. This objective focuses on ensuring that every student is allocated a specific seat that can be easily identified by both students and examination officers by generating clear seating information such as hall number, row, column in the system to minimize confusion during hall entry and seating arrangement. This also helps supervisor to verify student placement quickly, reducing delays before the examination begins. A clear seating display also supports streamlined management to enhance the organization of the examination process. Now, the second objective is to minimize the risk of cheating during examination by arranging students systematically and sequentially. Cheating risks increase when students sit randomly or too close to familiar individuals. This objective aims to address academic integrity by placing students in a structured seating pattern where allocation is systematic, sequential, and evenly distributed across rows and halls. By controlling the seating distance and the order, The system reduces opportunity for collaboration or communication between students during examination. As a result, examination officer can conduct fairer and more secure assessment while minimizing manual interventions. Now, I will explain about the flowchart for this report. The first one is in the flowchart need to have start. The flowchart begins with the symbol of start to indicate the system is ready to perform the seating arrangement process. The second is input data. The system will ask the user to input total number of students, number of exam hall, number of rows per hall, and number of columns per hall. These inputs are needed to determine how many seats are available. The third one is initialization and calculation. The system calculates the total seats per hall using by rows multiplied by columns. It then initializes students counter equals to 1 and hall numbers equal to 1. This prepares the system to start assigning students. The fourth one is decision. A student counter more than total students. The system checks whether there are still students to be seated. If yes, the process continues. If no, the system stops assigning seats. The fifth one is students assign student to seats. The student is assigned a specific seat position, which is row and column, an exam hall number, and an exam hall number. This ensures each student has a unique seat. The sixth one is display exam hall information. The system displays exam hall numbers and seats numbers, which is row and columns, also student seating list. The seventh one is decision. Is current hall full? The system checks if all seats in the current hall are occupied. If yes, move to the next exam hall and reset row, also column numbers. If no, continue seating students in the same hall. The eighth one is increase student counter. The student counter is increased by 1. The system repeats the process for the next student. And lastly, end. Once all students are assigned seats, the flowchart ends. This means the seating arrangement is complete. This flowchart shows how the system automatically assigns students to seats across exam halls by looping through students, checking hall capacity, and display seating information until all students are seated. And don't forget, the most important component in system flowchart is the process. This is because it represents what the system actually does, which are calculation, data processing, and action. Without process steps, the system has no function or logic.
Let me show you how our exam hall seating arrangement system works. Put the information needed. And ta-da! Successful without error, guys. Based on the code system, I will explain the elements we had included in this code. Firstly, throughout the source code, we have included details comments such as functions prototypes to explaining the purpose of variables. Besides that, we also have variables declarations like num student, halls, and rows that declare with a clear names in this code. The system interacts with the user via cin to collect hall dimensions and cout to display the final seating chart. For our exam hall arrangement operating system, there must be an element calculation such as total capacity, holes, multiply rows, multiply columns. We also use setW and left from the IOMAT library to ensure the seating chart looks professional and organized. Our code is modular. We use a call by value functions to print hall headers and a call by reference function such as display header and assign seat. The core engines use a combination of loops, which are a while loop and nested for loops. Finally, we use parallel arrays to store student information, linking the student names and metric numbers array by their index to keep the data synchronized.
In conclusion, the system assigns seats efficiently and reduces cheating. It also makes exam management more organized and fair.